Here we are, Friday night, almost 4 o'clock. You guys are home having a good time, and what am I doing? Taking a quiz for you guys. I'm taking a quiz. Keep on telling myself it's for you guys, and that's why I can get through this today. I'm going to do this quiz. I'm going to make the video. I'm going to send it off, and then you're going to watch this quiz after you take your practice test, just to see how you did, and to make fun of Benson when I make my mistakes. So those are the 2 reasons. Also to make sure you improve your understanding of the concepts right here. This is for you. This is why I'm doing it for you, okay? So let's take this quiz right now. And hopefully this will go pretty fast. Right here, first problem, I'm going to whiz through this quiz. Don't say anything about what I just said. Use the graph below to find the solutions to the system. Write your answer as an ordered pair, no solutions, or infinite solutions, okay? So I'm looking at this graph right here. I'm asking myself, hey, does this graph have no solutions, infinite solutions, or is there a solution to it? Well, there's a solution to it if the 2 lines, this line right here and the other line, this line right here, cross over each other. But they never do because they're parallel lines. Therefore, in this situation, see one of these 2 right here, no solutions or infinite solutions. Well, because they never touched, you don't have a line on top of another line, there's not infinite solutions. In this situation, it's no solutions. So that's what we're going to type in right below here, no solutions. But if you're horrible at typing, what you can do, you can copy this. Check out this. You copy it. Control C, that's a copy part, and then Control V, that's a paste part. And now it's pasted in there. We're going to check our solutions, and I hope I got the settings right. Oh, there we go. No solution is the correct answer. We're moving on. Go to the next one. Okay, let's clear some ink. Okay, now using the graph below, find the solutions to the system. Now, if it's a system, you know there is more than 1 line here. That's what it's telling you. There's at least 2 or more lines. Now, but when you look at this, you only see 1. So what does that tell you? There's another line behind it. You just can't see it. There's 2 lines right on top of each other. And if there's 2 lines right on top of each other, that means there is not just 1, not just 2, not just 3, but 4 or more. Actually, there's infinite solutions, guys. There's infinite. I shouldn't do it, all those dots, because it takes so long. So you're going to put infinite solutions on here. That's what we're going to type in. Infinite. There we go. Check that out. And we're on a good start. Okay. Let's move on to the next one. Next page. Okay, use the graph below to find the solutions to the system. Write your answer as an ordered pair, blah, 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 blah. Okay, this situation, are these 2 graphs crossing? You bet they are. And the solution to where 2 graphs cross is right where, well, I just gave it away. It's right where they cross. So we just have to figure out what that point is. So we're going to count over 1, 2, 3, 4. So it crosses over at 4. That's our x coordinate, and up 2. 1, 2, so up at 2. So the crossing point is 4, 2. That's your solution to this system of equations. Take that, pop that down here. How do you put it into Moodle? Just like this. 4, 2, like an ordered pair. Let's check that out. Make sure Mr. Benson didn't make any crazy mistakes. Nope, looks like it's checked off. So we're good to go. Moving on to the next one. Clearing the ink. It says, what is the system of inequalities? Match the graph. Okay, so we got to match this to the graph down here. That's not too bad. Let's take a look at this. We'll start with the red one. This is a red graph is a horizontal line. Because it's a horizontal line, we know its y is something, the height of this horizontal line, 1, 2, 3, 4, 5. So y is something 2. Okay, so now what we're going to do is we're going to pick a point in the shaded region for this line, this red region. It does not have to be in this purple region right here. Any point in the shaded region, and we're going to see, we're going to take that point and we're going to plug it into this right here. So the point right here is 0, 5. We're going to plug that in there and see if it's true, or make it true. Well, it'll become true, and then we'll know which way to go. So we'll take 0. This is our x, here's our y. 0 is not in here, or there's no x over here, so there's no place to plug the x, but there is a place to plug this y, which is 5. So I have 5 is something 2. Well, in this situation, 5 is greater than 2, so our absolute value is 5 is greater than or equal to 2, because this is a solid line. So our one inequality is y is greater than or equal to 2. Let's see which one of these options is y is greater than or equal to 2. It's either A or B. So we know it's either A or B, because this is less than 2 and this is less than 2. So let's look at the next one to figure out which one it is. So we're going to go back up here. We're going to look at this blue line now. The blue line's dotted. Does that give it away? Nope, that doesn't give it away because both of those inequalities, this one right here does not have a line underneath and this one doesn't have a line underneath. So the dottedness doesn't give it away. So what we're going to do is we're going to have to figure out, it's one of these shaded regions, so we're going to figure out which one of these will make the point 0, 0, which is in the shaded region, true. Let's try it out. Let's test this 0, 0 point into this equation. So we have 0 is less than 0 plus 1. Is this true? Well, we have 0 is less than 1. This is true. Because that's a true statement, this must be the solution. If you tried it out in this one right here, you would have 0 is greater than 0 plus 1. Thus giving you 0 is greater than 1. That is not true. That is false. That's why it cannot be this one. Therefore, this is your answer. Whew. That was a good one. Oh, delete that. Oh, delete that. There we go. Let's check it. We don't need to check it. We know we're right? But let's just do it anyway for confidence boosters. Go to the next problem. Okay, let's clear this ink, get it out of the way. Choose the graph of the following system of inequalities. So we have these graphs, and notice they're all the same. Like this is the same as, like this one is the same as this one, right? And they're all really the same. The only thing that's different is the shaded region, right? That's the only thing that's different. I circled too many things. Let's clear this. So we got to just figure out where would we shade. Would we shade in here for this graph, over here for this graph, over here for this graph, over here? There's a couple things you could do. You could just try to like graph this function. You could graph these two inequalities, up here, and just see which one it would be. Or you could pick like a point from each of these shaded regions, a relative point that you know would be in the shaded region, and test those points out up here. I'm going to do the graphing method. I like to graph this thing. So I'm going to graph this and this over on a little coordinate plane right here. It's just a freehand sketch. It doesn't have to be anything fancy. Does it, guys? Does it have to be fancy? Not in this situation. Oh shoot, I cleared my ink. That was a big mistake. I'm going to recover. So now let's graph this one right here. Before I can graph it, I got to solve for the y. So I'm going to subtract 3x on both sides. So I have negative y is greater than 3 minus 3x. I'm going to divide everything by negative 1. And then I got y is less than. Check it out. It changed. The line changed. Now it's the other way because I divided by a negative. Y is less than negative 3 plus 3x. So I got this line. It's less than that. I got my negative 3, 1, 2, 3. And this is the dotted line right here, as you can see. So it's the dotted line that goes up like that. And because y is less than it, I know I shade below it. So I'm going to be shading out down in this area. This is my shaded region. Okay. So that's that one. Let's do the other one. We'll graph this one. X plus y is greater than 1. So I subtract x on both sides. Subtract, so I got y is greater than or equal to 1 minus x. So I got a starting point at 1 right here. And a slope of negative x right there. Just something like that. And then, because y is greater than or equal to it, we shade above it. And what we're looking for is the double shaded region. And the double shaded region turns out to be right here. Let me make sure I do this right. Right there. Here's the double shaded region. So which one of these is the region we're looking for? That looks like it's this situation in this case. Right there. So it would be graph 1. Graph 1. Let's check. Let's see if Mr. Benson did this right. Yes. Good. That was too much work to not get it right. Okay. Let's clear this link. Get going on the next one. Clear ink. Okay. At a corner store, a bag of popcorn costs 95 cents. That seems important. And a bag of peanuts costs $1.25. That seems important. Suppose you want to buy X bags of popcorn and Y bags. Oh, so they're giving us variables here for us. That's nice of them. And Y is the bag of peanuts. So we know bag of popcorns is X and bag of peanuts is Y. And you only have $5.75. That's too bad. Wish you had more. Write inequality. Describe the number of bags, popcorn, and peanuts you could buy. Well, we know that our max number of things we can buy is $5.75 worth. Okay, that's maxing this out. But we can spend all of it, right? I don't know if we want to, but we could. We could spend all of that dough. right there. So whatever we spend, which is going to be over here, this is what we spend, has to be less than or equal to $5.75. Okay? Now for every bag of popcorn, X, you're going to spend 95 cents. So how much do you spend on popcorn? Well, you just do 0.95 times how many bags, which is X. And for every bag of peanuts, you spend $1.25. So $1.25 times the number of bag of peanuts will give you the total cost of the peanuts. And what you just do is you add these two together, and now you got your inequality there. So that's what we got to pump into this 0.95 X plus 1.25 Y is less than or equal to, that's how you put that in. Guys, did you get that? I'll do it again for you. Less than or equal to $5.75. And hopefully I'm right. Hopefully I got this one down. Yes! Gosh, it feels good to be right. Doesn't it? Let's get going. Okay. So we're in ink, clear ink. Going out of this. Oh, we can handle this one. This isn't even a system of inequality. This is just a single one. So I got y is greater than -4/3 x plus 1. Now you could go do the point thing, but remember my little thing. Once we have it in this form, when in slope-intercept form, or y equals mx plus b, but we're doing inequalities. Y is something mx plus b form. When it's y is greater than mx plus b, shade above line. Okay, and then when y is, okay, that's greater than, when y is less than mx plus b, shade below line. I can spell line. I graduated from college. I can spell it. There we go. And so this is the below, and this is the above. Okay, put these together. Okay, that's the shortcut for this. So now, using this information, I have y is greater than. Okay, and since it's greater than, that's this situation right here. And this situation is shading above the line. So let's look at all these lines. Let's get this one, this one, this one, and this one. Which ones are shaded above the line? Well, here's our line. Is it shaded above the line? No, this looks like it's below, so it's not this one. Here we got this one. Is it shaded above the line? Yeah, it is shaded above the line. So this one checks off. It could be this one, right? Now let's come over here. This one looks like it's shaded above the line. So this one checks off too. So it could be this. Oh, could be this one. We're not exactly sure yet. And this one's shaded below the line, so it's not that one. So it's either these one. It's one of these two. Which one is it? Well, let's go with this part. When we look at this, there's no line under here, and because there's no line, we know it is dotted. Dotted. Yeah, that's right. And because it's dotted, we know it's got to be this one right here. This is the one because this is a solid line. If this is a solid line, there should have been a line right underneath here. Y is greater than or equal to. So we're going with graph 3. That's my final answer. Wait, why is it out of order? Okay, check it. Delete. There we go. Okay, so that's how you do that type of problem. Clear in ink, going out. Oh, so these get you guys. That I don't know how many times I have to answer questions on like a problem like this. Okay, when you see this vertical line right here, see this vertical line? You got to remember that vertical lines like this are of a different type of form. It's a special form, special in a good way. This is like an X is something, a number, okay? And so it's going to be, and because it's a solid line, we know it's X is greater than or equal to or less than or equal to a number. And that number, this number right here, is where it crosses over the x-axis. And in this situation, it crosses over at -2. So we know we got X is something -2. Okay? So we just got to figure out what that something is. So what I like to think about is, what compared to this value right here, let's look at all the other values on the x-axis. Are these values greater than this value right here, or are these values less than? Well, 4 is definitely greater than -2. Therefore, our x is greater than -2. Now, if that reasoning doesn't work for you, for some reason, even though it's perfectly logical, but it could happen, what you can do is you can still take this point 0, 0, like we talked about before. You can plug this point into this formula right here. Well, the y, there's no place to put the y, that's okay, but there's a place to put this x of 0. So you put 0 is something, negative 2. Well, 0 is greater than negative 2, so you would make the inequality that way. So you would have x is greater than or equal to negative 2. That's the other way to do it. So our final solution is x is greater than or equal to negative 2. Now, hey, just throwing this out there, horizontal lines have no slope. These are the form y is something, the number where it crosses over the y-axis. Okay, so something to think about for that one. But that wasn't this problem, so we're going to put x is greater than or equal to negative 2. Check me. Yes, okay, let's moving on. Moving on up to, I don't know the words, ink. Okay. Here it says, use substitution or graphing to find the solutions to the system. Write your answers are ordered pair, no solution, or infinite solution. So it's one of these three, and if it's this one, who knows what it could be. When I give you this, I just give you suggestions. These are suggestions. If you want to eliminate, go ahead and eliminate. It doesn't matter how you get Chipotle as long as you get there, right? That's what I always say. So just do the order or whatever makes sense to you. But I'm just giving you a suggestion. And here's why I'm giving you the substitution suggestion. We already know what y is in terms of x. Y is equal to x minus 2, right? So this y also is equal to x minus 2. And so I can take this right here, this equation, and I can change it to 4x plus 2 times my y, which is x minus 2. X minus 2 equals 20. So I get 4x plus 2x minus 4 is equal to 20. Notice I just distributed that 2 in here and here to get 4 there and the 2x there. I'll combine these two together to get 6x minus 4 is equal to 20. And then I'll add 4 to both sides to get 6x is equal to 24. 6 times what is 24? Well, that's 4. So I know my x is equal to 4. So I got my x coordinate. Now I just got to see what my y coordinate is. What's nice is I can take this, I can plug it in here or here. Now if you really want to challenge yourself and maybe make a mistake, put it in the top one. Yeah, give it a shot. But I highly recommend doing this one, because you just take the x and put it in for this x here. So you have y is equal to 4 minus 2, and you're probably saying, Benson, why are you wasting time? It's just 2. Yeah, y is equal to 2. And so my answer would be 4 for my x coordinate and 2 for my y coordinate, 4, 2. Put it in an order pair just like I did, 4, 2, close it off, and then check your answer, which you won't get to do. I'm not going to give that power to you. There we go. Or you didn't get to do. Hopefully you didn't. Maybe you did. Maybe I forgot to change the settings. There's a good chance I'll forget. So we'll see what happens. Okay, here's a linear programming problem, guys. It's a little bit different, but I'm giving you a feasible region for a set of constraints, okay? I'm giving you a feasible region for a set of constraints, and here are the vertices for that feasible region. So, just imagine, you had a graph, right? And then you have these vertices right here on the graph, just so like let's say this was your feasible region at the end. I know you've never seen one that looks this crazy, but let's just say it was, okay? And these points correlate to that one goes to that one. I know they don't, guys, but let's just say they did, okay? Remember, we test these points in our profit function, and by testing them in a profit function, we figure out which point will maximize our profit, because only the corners will maximize and only the corners will minimize, okay? So we're going to take these points, put them in here, and then see what we get, okay? And then one's going to be a max and one's going to be a min. Okay, so let's just go ahead and test those. I'm going to have to clear my ink because I just did a lot of scribbling there. So what we're going to do is we're going to really just take this point and put it in here. So this is how it works. This function is 3x plus 2.5y, and we'll see what that gets. So we'll take this in there, I'll put a negative 2 here, a 0 here, and I get negative 6. So that's for this point right here. I'll maybe keep track of it right here. Negative 2, 0. Now let's try the next point. Let's try this point, 3, 3. So 3, 3. So I have my 3 from here, underline plus 2.5 from here, underline is equal to what? Well, let's see. We'll take this 3, put it here. Take this 3, put it here, because this is your x and your y, right? Your x and your y. And so 3 times 3 is 9. 2.5 times 3 is 6, plus a half of 3 is 1.5. 6 plus 1.5 is 7.5, plus the 9 that you got when you were doing this one would be 16.5. Oh, I did that right in my head. Okay, so that's this one. So far this is your min. Here's your max. Let's see what keeps on going. Let's do this one now. So I got 6, 2. I'm going to plug that into my objective equation. So I got 3 underline plus 2.5 underline equals. I'll take this 6, 2 in here. I'll put the 6 there, and then times 2 right there. So 3 times 6 is 18. That's already surpassed that sucker, so that's gone. And then 2.5 times 2 is 4, plus a half of 2 is 5, so 18 times plus 5 is 23. Hopefully I did that right in my head too. Okay, so I have one more, and I'm running out of colors here to use, so I'll go back to my red color. We'll check out 5-1. I can almost guarantee 5-1 is not going to be in there because it's going to be less than this one. But let's just see what happens with it, just because we love to do math and do this stuff. That's 2.5, especially on a Friday at 4:19. Friday, I'm here at 4:19 on Friday. Just kidding, guys. I love it. Okay, so 3 times 5 is 15. 2.5 times 1 is that's 17.5 altogether, if I did this right. So now, looking at each of these points, which one gives us the highest value? This point right here gave us the highest value. So this would be, we got the 6.2 as my max. So it's either this or this for the maxes. So now we just got to figure out which one gives us our min. And it looks like here's our min right here, our lowest value. So -2 gives us our min, so it must be this one, F. That's how you go about doing this. Your business here. Check that out. Oh, good. How'd that work? If I got it wrong, I might give up on math altogether. I would never. Okay, here we go. Going on the next problem. Again, I give you a suggestion. Use substitution or graphing to solve this. Clearing. Did I give you a good suggestion? I disagree with my suggestion. I apologize. I would use elimination. And what I'm going to do is I'm going to try to eliminate my y right here, because I know that if I multiply this top equation right here by 6, that the coefficients in front of the two y's right here and right here will be the same. So let's do that. I'll multiply the top one by 6. This goes here, multiplies to my y. I can draw a line, and then right there. So I got 6 times -5. This gives me -30x. 6 times y is plus 6y, and 6 times -2 is -12. And what I'm going to do is I'm just going to rewrite this bottom one, not change a thing on it. Okay, so I got -3x, excuse me, plus 6y is equal to -12. Okay. Okay, so here we go. We are going to get rid of the 6's, the y's right here. To get rid of 2 positives right here, I'm going to have to do a subtraction. We're going to subtract both of these things. So -30x minus -3x is really -30x plus 3x. We're dealing with this right now. So -30x plus 3x is -27x. Right there. And then 6y minus 6y is 0y. So those are kind of gone, right? And then -12 minus -12 for this one is 0. So I got -27x is equal to 0. Therefore, that's the therefore sign, guys. X is equal to 0. Because 0 times -27 will give you 0 right here. So we know our x coordinate, it's 0. Now to figure out your y coordinate, you just take this x and you plug it into one of these 2 equations, here or here. So let's plug it into, I don't know, let's do this one. We'll plug it into there. So I got -3 times 0 plus 6y is equal to -12. This is gone because it's 0, so I got 6y is equal to -12. Therefore, y is equal to -2, because 6 times -2 is -12. So I got -2 right there, and that is my ordered pair. So 0, -2. Check that. There, good. Moving on to the next one. Clear ink. So, it says, use substitution or graphing to find the solutions to the system. Write your answer as an ordered pair. So just like the other one, what are we going to use? I'm going to use substitution in this one because y is already solved for. I know y is equal to this, and therefore this y is also equal to this. So I'm going to take this and put it in for the y right there. And when I do that, I got 4x plus 2 times negative 2x minus 7 equals 6. So I pretty much just plugged this in to the y, and I rewrote the equation right here. I'll distribute this here and here. So I got 4x plus, ooh, that's not plus, correction. The minus sign right there, right? 4x minus 4x minus 14 is equal to 6. Now my 4x's cancel, and I get negative 14 is equal to 6, and I say, what? That's not true. This is false. So what does this tell us? Well, this tells us that these two lines are either a no solution situation or an infinite solution situation. That's what it tells us, the false. Getting this situation, okay? Now, because it's false, we know that there are no solutions, okay? But if this was true, if you had something like negative 14 equals negative 14, well, then that would be a true statement, and then it would have been this situation, the infinite solutions. In other words, you have two lines right on top of each other. Here you have two lines, they're parallel, but they never cross. So we're going to put no solution in for this one, and we're going to move on, because we're going to go home. I'm going to spell solution right. No solution. Was it? Yeah. It wasn't plural. Great. Okay, moving on. Two more problems, and then freedom. Okay. Here goes. Use elimination to find the solution to the systems. Write your answer as an ordered pair, blah, blah, blah. Okay, let's do this. So we got this problem right here. We want to find the solution, if there is one, or if maybe there's infinite. I'm going to try to focus on one variable. Let's focus on, oh gosh, either of those kind of suck. I'm going to have to multiply both of these out by a number. First off, I'm going to rewrite this a little bit bigger because, gosh, that's kind of small. Plus 3y is equal to 2, and I got 2x minus 4y is equal to negative 20. Okay. Now, I'm going to focus on getting rid of the, how about, let's do x variable. Either one's going to work in this one, but we're going to do x. So we need to get this and this to be the same. Therefore, this top equation we're going to have to multiply by 2. So let's multiply the top one by 2. And the bottom one, to get the least common multiple, we multiply it by 5. Okay, so let's write the top one over here. When we distribute this here, here, and here, I get 10x plus 6y is equal to 4. And then when I distribute this here, here, and here, I get 10x, thankfully, minus 20y is equal to negative 100. Okay. Now I got to add these two functions together. Actually, I'm subtracting them, right? Because I wanted to cancel these out, and since they're the same, they're not opposites. One's not 10 and one's not negative 10, so we're going to subtract. When I subtract, this gets me 0x. When I subtract this, I get negative 26y. When I subtract this, this is equal to negative 104. Okay. Now, check this out. We're going to divide by both sides by negative 26. Divided by negative 26. And did you know that that is equal to positive 4? So we got our y coordinate. We know our y coordinate is 4. Now we got to get our x coordinate. So we got to plug it into one of the two equations. Let's plug it into the top one. I like the top one best. Either one will work though, right? Either one will work. So we're going to plug this 4 into the y right here. So I got 5x plus 3 times 4 is equal to 2. So I got 5x plus 12 is equal to 2. I got 5x is equal to negative 10. That means this 12 over here by subtracting 12. And then divide both sides by 5. So I got x is equal to negative 2. Right there. The negative. So put that in there. We got negative 2, comma 4. Negative 2, comma 4. Here we go. One last problem to go, guys. Let's get through this. What does it even want us to do? Okay, use the given feasible region. The feasible region is right here. And objective function, I guess is profit in this situation, excuse me, to determine the maximum profit that can be made. Oh, this is just like the other problem without the graph. We're just going to take this point, the corners of the feasible region. You just got to know it's corners right now. We're going to take this point, this point, this point, and this point, and see which one will maximize profit. Well, we're not going to be stupid and put this one in, because 0, 0 in here is going to give you nothing. Okay, so that's idiocracy right there. We're going to try this point, and this point, and see what we get. So our objective function is 2.5x plus 3y. So the same idea is going to apply right here. Let's start with the 0, 440. We're going to try that point 0, 440. We're going to plug it into this function right there. It's a weird arrow. So we got 2.5 times something plus 3 times something will give us our profit. And that something in this situation is 0 for this one and 440 for this one. So 440 times 3, that's 1200 plus another 120, which is 1320. Hopefully I did that right in my head. Okay, so far that's the leading one. That's going to max it out for us, but we got another point to try. Let's try this point right here. I got 270, 260. Oh man, this is going to be tough to do in my head. So we got 2.5 times something plus 3 times something is equal to something. I'm going to plug these points into those two. So I got 270 and then 260. Okay, so 270 times 2 is 400, 540. Half of 270 is 135. 540 plus 135 is 675. So that was this one. Okay, 3 times 200 is 600. 3 times 60 is 180. 600 plus 180 would be 780. Now we add these two together. 675 plus 780 is, this would be 13, but we're going back to 1400. 7 plus 8 is 55. 1455, I hope. Yeah, 1455. Okay. If I made a mistake, it's because of some arithmetic error. Okay, we got one more to do. We're going to test out this point right here. Right now, we're at 1455 is our max. We can test out 400, 0. So we got 400, comma 0. Again, we're going to test it into our equation. So we got 2.5 times something plus 3 times something is going to give me my profit. And we're going to put the 400 here, and then the 0 there. 2.5 times 400 is like 800 plus another half, which is 1,000. And this is just 0, so you really have to do that one. So our answer should be 1455. Now, hopefully, and some of you probably already know if I did it right or not. Hopefully, I did the math right in my head. Let's check it. I'll be pretty happy if I did. Yes! There we go, guys. So, hopefully I just want you to take advantage of this. Hopefully you do well on the practice test and you don't have to totally take advantage of this one. But if you don't do well, if you struggle on it, here's a resource for you. Please take advantage of it, use it wisely, and then let's get ready for that test that's coming up in 2 days, okay? Everyone, I hope you all had a great weekend, and I am out of here.